Hello everyone, I am Muhammad Afshan from Savita Engineering College, 3rd year BE Computer Science Engineering with specialization in cyber security. Today I am going to explain the A-star search algorithm, which is one of the most widely used pathfinding algorithms in artificial intelligence. In this presentation, I will construct a custom graph, perform A-star search step by step, explain its working principle, and discuss its real-world application. What is A-star search? A-star search is an informed search algorithm used to find the shortest path between a start node and a goal node. It combines the actual path cost and estimated remaining cost to make the intelligent decisions while searching. So its key features are it's a complete algorithm and it's an optimal algorithm, and it works based on the heuristic based search, and it's an efficient pathfinding algorithm. Before we solve the problem, let us understand what A-star search is and why do we need A-star search. So many search algorithms explore too many unnecessary paths. So A-star search reduces the unnecessary exploration, uses heuristic to guide the search, finds the shortest path efficiently, and it's mainly used in GPS navigation system, Google Maps, robotics, video games, and autonomous vehicles. And traditional searching methods may waste time exploring unnecessary paths. So A-star search overcomes this problem by using heuristic values to guide the search towards the goal. So A-star search evaluates every node using three components. At each step, it expands the node with the smallest f of n value, balancing cost so far with estimated remaining distance. And the evaluation function here used is f of n equal to g of n plus h of n, where g of n is the actual cost from start to current node, and h of n is the estimated cost from the current node to the goal node, and f of n equal to the total estimated cost. So the decision will be taken like based on the smallest f of n value will be selected first. So let us construct a graph and we'll perform the problem. So this is the graph used for the demonstration of A-star search algorithm, and A will be the start node and G will be the end node, and the numbers on the edge represents the cost between two nodes, and the numbers associated with the nodes represent the heuristic value, and these are the heuristic value used by the A-star search algorithm for this problem. And you can notice that as we approach the goal node, the heuristic value starts to decrease. And this is the formula we are going to use to solve the problem. For your kind understanding, I have mentioned the edge cost for each nodes. So let us start the problem. The start node A has been added in the open list, and the total cost is 0 because it is the start node, and the heuristic value of A is 5. So the f of n formula is g of n plus h of n. So we will add both the values and the total value will be 5. There is no any other extra nodes in the open list, so we expand the value A. A have two neighbors. We can see that B and C. So we will open the B. The cost from start node to B is 1, and the heuristic value of B is 6. So the f of B value is 1 plus 6 equal to 7, and same the cost of C from the start node is 4, and the heuristic value is 4. The total estimated cost f of C is 4 plus 4 equal to 8. Now these two nodes will be added to the open list, and the A-star search algorithm chooses the node which has the lowest f of n value. As we see that B of 7 has the lowest f of n value, B is chosen. Next we will expand the node B. So B has two neighbors, D and C. Again we will check the cost of start node to C. Here we are going from start node to C using going through B, and 1 plus 2 equal to 3, and the heuristic value of 4 is heuristic value of C is 4. So the total estimated cost will be 7. Previously the C value was 8. The new path through B was better, so we are updating the value C. This is because at the start we look at the cost of C from A directly, which had a higher value. But if we consider this path A to B and B to C, this has much shorter path. So we are updating C equal to 7. And next at the neighbor D, the total cost from the start node to D is 4, and the heuristic value of D is 3. So the total estimated cost will be 7. And in the open list, we will add the C of 7 and D of 7. We choose D because it will be harder if we go towards it will take a longer path to reach the goal node. So we choose D, which will be a shorter path to reach the goal node. Next, after expanding D have two neighbors, F and G, and the total cost from start node to F is 6, and the heuristic value is 1, and after adding it we will get 7. Similar, the total cost from start node to G is 8, and the heuristic value of G is 0, and the f of G 8 plus 0 equal to 8. So we see that the heuristic value is decreasing as we move. So in the open list we have C of 7, F of 7 and G of 8. We will choose F of 7, and we will expand F of F, and F has only one neighbor, which is G, and total cost from start node to G is 7, and the heuristic value of G is 0, and the f of G value is 7 plus 0 equal to 7. Previously we had a G equal to 8, so this has a lower cost, so it will be a much better solution. So the new part is better, so we update the G value. So open list is C of 7 and G of 7. We choose the G value. G is the goal state and the goal state reached. So the optimal path will be A to B, B to D and F to G. So the cost calculation, A to B is 1 and B to D is 3 and D to F is 2 and F to G is 1. So after adding all, we will get a total estimated cost 7. This will be the optimal path because it chooses the lower Fn value, and there is no any alternative path that have a much smaller value than this path. So why A star search is this much effective? The answer lies in its balance between the actual cost and estimated future cost. Instead of blindly searching every possible path, A star intelligently chooses the most promising route. This reduces unnecessary exploration and improves efficiency. So the practical applications of A star search are GPS navigation system, which calculates the fastest route between the locations in real time, and robotics enables autonomous robots to plan collision-free movement paths, and video games controls the NPC movement and real-time decision making for characters, and puzzle solving, finding optimal solutions for sliding puzzles and planning problems. And the significance of A star search are finding the shortest path efficiently, reduces unnecessary exploration, guarantees optimal solutions with admissible heuristics, and balances speed and accuracy better than many other search algorithms. So hope you all understand what A star search is and how it is used, and what are the components of A star search, and how to solve any graph based on the problem I demonstrated. So thank you all.